Greetings and welcome to the video of my second module on digital electronics realization using Python. And following the first module, in this module we are going to discuss about how to realize logic gates using Python code. That is the objective of this module. So how to realize logic gate by using the same program. That is our intention. And also we are going to see something apart from that, how to practically realize the circuit into other modes. That is also going to discuss in this video. So this video is little bit a experiential walkthrough, so the users can able to do along with me so that they can able to get insights what I am doing and how to realize the logic gates by means of coding method as well as by means of realization method. Both things we are going to see in this module. So first let us check a small theory about these logic gates and then we can able to see what are all the things to be done and how that can be realized, that we will see in the vast manner. So first let us check what is mean by a logic gate. So first there are several logic gates. Usually logic gates are of 7 types. One is called the AND gate, and another one is called OR gate, and another one is called NOT, and another one is NAND, and another one is NOR, and another one is XOR. These are the 6 different. XNOR is there, you can also include. So 7 basic logic gates are there, used for doing different mathematical manipulation process. So usually how everyone teach means AND gate means it will do multiplication, but that concept is somewhat mess up. Why means AND gate doesn't do any multiplication, it is doing AND logic process. So what is mean by AND logic means, according to Boolean theorems, these logic gates will work according to Boolean theorem. So what is Boolean theorems discuss about means, if both A dot A is equal to A, similarly 1 dot 1 is equal to 1, A dot 0 is equal to 0, 1 dot 0 is equal to 0. Like that, Boolean, the scientist has formulated certain theorems and postulates in order to perform certain mathematical computation. That is called as Boolean algebra. So based on the Boolean postulates and laws, these AND gates ICs, these are called integrated circuits. These ICs are fabricated in such a way that these gates will follow this Boolean algebras and theorems in order to do certain manipulation. And as this manipulation correlates with the multiplication process, this AND gate is one of the criteria to be used for any mathematical multiplication. Basically, AND gate doesn't do any multiplication. It is worked on the principle of AND logic. What is the logic means? This is the logic. If both parameters are same, then it will give you a same result. So this is the thing what you have to understand. Similarly, OR gate, NOT gate, NAND gate, NOR gate, XOR gate, XNOR gate, everything is working on this Boolean algebra and theorems and postulates. So this is what the main thing. Similarly, for OR gate, instead of dot, we have to replace plus. A plus A is equal to A. Then A plus 0 is equal to A. There A dot 0 is equal to 0. Here A plus 0 is equal to A. As it is correlating addition multiplication, addition process, AR gate is used wherever addition steps are required. And NOT gate is used for inversion process. NAND gate is used for negative of AND. NOR is negative of OR. XOR is either or process. That is AB bar plus A bar. So in that manner, we can establish a brief introduction. We can see a brief process about what is meant by AND gate and how it is going to do the things. For that, we are going to see one thing called a truth table. What is meant by truth table in digital electronics means, the table that describes the operation of a particular component or a particular IC. That is called as truth table. So here first I am going to introduce a concept called AND gate. So the symbol of the AND gate will look like this, and this is A and B, and this is, we are calling it as Y. So if I want to write the truth table, what I have to do, I am going to write A, B and Y. So this is 0, 0, 0, 1 and 1, 0, 1, 1. So AND gate means dot operator. So 0.0 is 0, 0.1, 0, 1.0, 0, 1.11. When both conditions are high only, you will get a high output. That is why first input and second input should be in the high level. Then only you will get the high output. Then you can use the logic called AND logic. So this is the thing where we can able to use this truth table is formed by means of Boolean logic. Based on the Boolean logic, this truth table came into picture. By means of Boolean theorems and postulates, we come to a conclusion that when both the inputs are low level, output will be low. When both the inputs are at high level, output will be high. For remaining all cases, the output will be remains low. So like that we can form OR gate also. So the OR gate, the same thing, and the OR gate symbol will look like this. So similarly A, B and Y. So if I write the truth table, I will get like this: A, B and Y. So 0, 0, 0, 1, and then I can write 1, 0, 1, 1. Sorry, my handwriting is somewhat slanting, so I will try to rectify that. So here 0, 0 means 0, 0, 1. Any one input remained high, either first input or second input. In the word itself, you will get the word OR. So if it remains high means you will get high. Similarly, this also, both levels, or either or, this or this. Anything high means you will get high output. Here both are high, so you will get the high output. So this is called as OR logic. And for the NOT gate, if I give, there is only one input and only one output. If I give 0, you will get 1. If I give 1, you will get 0. This is called as NOT gate. So NOT gate is given by the symbol, one triangle followed by a, this is A, Y is equal to A bar, that is opposite. Okay. Then similarly, NAND gate, NOR gate, you can discuss. NAND gate is nothing but negative of AND gate. That means what you have to do, I have to put AND gate symbol followed by a inverter. This one. So AB, what is the symbol? A dot B bar, opposite. So how I can write AB? So 0, 0, 0, 1 and 1, 0, 1, 1. This is probabilistic. Either 2 or 0, one is 0, another one is 0, both are 1. So what I will get? Y is equal to A dot B opposite. So usually you will get 0 here, that is 1. This is 0. This is 1. Sorry, this is 1 and this is 0. What is meaning? Both are false means you will get true. Either 1 or is true means you will get true, and both are true means you will get false. That is totally opposite to that of the NAND gate. And another one is NOR. NOR means same thing. For OR gate, you can introduce one NOT symbol. So AB means you will get A plus B bar. Similarly, you can tell the truth table by yourself. So what is the thing is, here I can see. So 0, 0, 0, 1, 1, 0, 1, 1. So Y is equal to what? A plus B, the whole bar. So 0, 0 means 0 will come. This is 1. This will become 0. This will become 0 and this will become 0. Then final gate is nothing but XOR gate. XOR gate is nothing but what? Either or condition. So AB, here Y is equal to A exclusive OR gate. That means either or condition. That means here I will move this. So 0, 0, 0, 1 1 0 1 1. Either odd means what? Either this or this should be high. So remaining all will be 0 there. So this 1 1. So these are called as logic gates and its truth tables. Now, usually we will memorize all these things. Okay, so instead of that, what happens if these things are working or not? If I want to realize that, then what I have to do? You need to go with the two concepts. One is called as realization using coding method, and another one is implementation. Directly we can take the IC and we can construct and work on that. Both things we are going to discuss. So here what I am doing is I am going to take this Google Colab and I am going to explain you this coding you already know. This is nothing but the coding used for describing binary, decimal, hexadecimal, octal, which is one previous lecture you can go through this program. So same program I am copying here, but a little bit manipulation I am going to do. What manipulation we can check here. So instead of binary, decimal, hexadecimal, octal, I am going to change AND, OR, NOT and XOR. NAND, NOR if required means we will add further. How to add I will explain you. So this enumeration process same. Here I am giving 4 choices, 1, 2, 3 and 4. If I want to include something means you need to give 5 choices. It depends. If choice is greater than 1, sorry, less than 1 or choice is greater than 4, it should not be greater than 4 or less than 1. Either it should be 1 or 4. Then you have to go ahead. Otherwise you have to print it is a invalid choice. So after doing this, after getting the number, you have to come here and you have to get the first input. So enter first input. It should be either 0 or 1. So as per the truth table, it is what? 0, 0, 0, 1, 1, 0, 1, 1. So it should be either 0 or 1. Only these two numbers should be entered. If 0 and 1 are not entered, if I entered some 2 or 3 or 4 other than 0 and 1 means the input must be 0 or 1. You have to print that and then you have to return. Here operation is equal to choice minus 1. Why I am giving this choice minus 1 means here it is in the form of index. So here it starts from 0, 1, 2, 3. That means choice minus 1 means this is nothing but whatever choice I am entering. For example, I am entering 2 means what you will get 2 minus 1. 2 minus 1 is nothing but what? 2 minus 1 is nothing but 1. Okay, so similarly, like that, the operation, what are all the list in the operation? That choice minus 1. Choice is nothing but what? Suppose I am entering the choice as 2. So 2 minus 1 is nothing but what? 1. So that is nothing but my actual choice. Okay, so if I want to enter, operation is different, choice is different. That is, you have to carefully listen. Choice is nothing but 1 to 4. Okay, so choice is 1 to 4. Suppose I am entering choice is equal to 2. That means what you will get 2 minus 1. 2 minus 1 is equal to what? Operations of 1. Operation of 1 is nothing but what? 0, 1. So actually I want to enter the choices OR gate. So I am entering 2 here. Choice. Entering the choices 2. But while coming here, what happened? 2 minus 1 is 1. But operation starts from 0. So 0 and 1. 0, 1 means actually what operation will come? OR will come. Like that only you have to do. Since these lists are in the form of indexes. So 0, 1, 2, 3. But we are giving here the choices. Enter choice 1 to 4. Otherwise you have to give from 0 to 4. That is meaningless. There is no choice by the name 0. That's why we are giving 1 to 4 and we are subtracting here. This is another form. So if operation is not equal to not, operation not equal to not means for not gate how many inputs are required? Only one input is required. So you don't want second input. If it is not equal to not means you have to get the second input. Otherwise, input 2 is equal to none. So if it is not equal to not means what you have to do, you have to input the second input. And the same thing, if it is not in 0, 1 means you have to do all these steps. And then if operation is equal to AND, then result is equal to input 1 and input 2. Operation is equal to OR, input OR symbol is nothing but pipe symbol. And if it's equal to not, result is equal to 1. If input 1 is equal to 0, else. What it is the meaning? Result is equal to 1 if input 1 is equal to 0. If input is 0 means result will be 1. For all other condition, it will be 0. That is input 1 is equal to 1 means what happened? It becomes 0. XOR gate means cap symbol. Then you have to print the results and you have to call the same calculator like earlier program. So this is the thing what you are going to do. So if here I have simplified the operation and or not XOR. If you want, you can include NAND also. That we will see in the separate portion. So just a simple only. Here you can enter comma NAND. That another program is there. In that I will explain. So here no need to mess up with this process. So after doing this, what you can do, I can run the program. This is very simple program. So you have to define a list, what operation you are going to perform. And then you have to enter your choice, what choice you want, either AND gate or gate or NOT gate or XOR gate. And then following the selected choice, you have to choose whether to choose 2 inputs or only 1 input. And after that, by means of input built-in functions, automatically the process will be done. Let us check what happened. So I am executing the program. It is asking 1, 2, 3, 4, what choice you want. Suppose if I want to do OR gate, so I am getting yes. So first input it will ask. So what I am giving? So I am giving 0. Second input it will ask. I will give 1. So third, the answer will be what? 1. That is the result of OR gate. Once again, I am running here. I will check out one more condition. If I want to perform NOT gate, so I am entering 3. So first input may be 1. So directly answer will come to 0. Why? How the process is going on? If it is not equal to not, it will get the second input. If it is equal to not means input 2 is equal to none. Directly it will go into the operation. So this is how we are going to perform the AND OR gate operation by using simple Python program. So the truth table can be realized very easily, but someone may ask, if the truth table looks like this, it will be very beneficial. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. If it looks like this means it is easy to readable. So one by one we are realizing means that is somewhat difficult. So shall I write that program? Means yes, you can write here the same program. So you can see here, if gate type is equal to not, I am printing truth table here, definition of truth table, and inside that I am getting one variable called gate type. After that I am calling the gate type again and again. That is the usage of definition. If definition one name, after that inside one variable is declared, function is declared means that function will be called again and again according to the different purpose. So if gate type is equal to not, then actually this contain 1 input and 1 output. So first I am printing that not gate. So with whatever I want, I can print like this. So 0 means 1, 1 means 0. For writing AND gate OR gate, that means this will become very lengthy process. I cannot write 0, 0, that is meaningless. So it has to do by automatic. So what I have to do is, here I am writing printf function, print function of, I am calling the gate type, whatever I am writing here, I am calling here, and then I am writing gate truth table. And then print input A, input B. Here you can see here only 1 input, but here I am getting 2 inputs. One is input A, another one is input B, and another one is my output. Following that, these are optional. So for A in 0, 1, same thing. For B in 0, 1, only two integers are possible. And if gate type is equal to AND, I can output int of A and B. Else if gate type is equal to or, output is equal to gate type is equal to XOR cap symbol. Gate type is equal to NAND, not of A and B, like that. Okay. So like that I can do. First I will run this program and I will extend this program to NOR gate for your better understanding. Okay. So I am running this. So if I run this means definitely I will get the truth table. NOT gate means this. AND gate means you can see 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. OR gate means 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. XOR gate means 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. And finally, NAND gate means 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0. Like that, you can realize. Suppose if I want to extend this program further, I want to include NAND gate, NOR gate. So what I have to do, I need to include this NOR. Okay, fine. After that, what I am doing, I am just pressing one enter. And here, else if I am writing. Same thing I am doing here also. Else if. Okay. So automatically, sometimes this Gemini will give you suggestion. If not, you have to type. So gate type is equal to. So you need to include what are all the things appear there. That is NOR. And then colon. Colon. Okay. So here colon. So what is the thing? Output is equal to int of not of A or B. Okay, so I will type here. So here I will type output is equal to int of not of A or B, opposite of OR gate. Okay, so here also I have to type this print truth, that is Gemini. Okay, automatically it will come. So print truth table of. I think it is understandable. Right? Very, very easy thing only. Once you got here printf of whatever you want, you can type here. A means it may be either 0 or 1. B, it may be either 0 or 1. Output will be according to the function, according to this for loop. So if it is other than this means invalid gate type, it will come. Okay, right. So now I am running this program. So you can see here that NOR gate is come 0, 0, 1, 0, 1, 0, 1, 0, 0, 1. All gates are now displayed. Writing of truth table. Okay, this is very, very simple and easy realization. So this is how you can realize the truth table with the help of Python. So what are all the truth table you are writing here? By using inbuilt function, you can able to realize how it is working with the help of the Python tool. Now what I am going to do is another thing. Sir, I need to implement this and I want to see the results. Then you have to go to a tool called tinkercad.com, which is a open source tool, freely usable. So in the Google, you can search for this Tinkercad, and by using the same phenomenon, by using your Google account, you can just open a Google account and you can start doing this experiment very easy. So what I am doing is I am going to recognize something. So for that you have to realize something. Instead of writing here directly, I can type here. So first, what is the IC number of AND gate? That is 7408. That means that is AND gate. Then OR gate means 7432. 7432 is OR gate. And then 7400, that is NAND gate. Okay, and then 7408 over 7432 over 7402 is there. That is nothing but NOR gate. And 7404 is there. That is nothing but NOT gate. So these are all the things generally used while doing the experiments. While doing the experiment for selecting the ICs. So better I can write a note here so that you can able to follow. What are all the different ICs? 7400 is nothing but NAND gate. Okay. And then 7408 is nothing but my AND gate. Okay. And then fine. Then 7432 is nothing but my OR gate. Okay. Right. It is appended, right? And then this is called a notes option in Tinkercad. If you want to tell someone what I am doing means you can do here. Next. After this 7 means it will gone. Okay. Okay. Now control is set. After that, one more note I will take. Otherwise, this is somewhat mess up now. So keep here. Another note I am taking. Okay, it is something. How it will be, I will check out once. Okay, now it is clear. 7432, since it is online, it will take some time. That is the problem. Then 7402, that is nothing but my NOR gate. And or not everything over. And then finally 7404. 7404. 7404 is my NOT gate. And finally 7486. Okay, here I will type 7486, which is nothing but my XOR gate. These are all the maximum things you need to remember when you are following this Tinkercad. So it is coming, fortunately, but I don't want this. Okay, fine. So this note, you just remember whatever you want. Whenever you want, you have to remember all these things. So this is easily movable, and you can move whenever you want. You can enlarge whatever you want. You can, but this is online tool. That's why it is showing some mess ups. So okay, now it is. I will keep this in the corner. This corner, it will be useful. Okay. So first, what I am going to do is I am going to realize this AND gate operation. How to realize this AND gate operation? Let us check. So first, I am taking one breadboard. Okay. So you all know, those who don't know electronics, don't know problem, just listen what I am doing here. This is a breadboard used for fixing the components. So in this breadboard, all these top lines are interconnected, and all the vertical lines in the center portion, all the vertical lines are interconnected, and there is a gap in between this section and this section. And again, this subsection is all horizontal lines are interconnected. So what is mean by interconnection? I will explain you now. Next, for doing this experiment, I need this IC. So what I am going to do is I am going to take this IC 7408. That is nothing but AND gate. So you have to take this AND gate and you have to fix here like this. Now you can imagine why this center separation is given. So all these terminals, that is vertical lines, are interconnected and horizontal lines are not in touch with each other. That means this pin and this pin are not in touch. This pin and this pin are not in touch. Suppose if I want, if for example, if I am rotating this, okay, I am rotating this and I am fixing like this, means what happened, this and this are short circuited, this and this get short circuited, so your IC will burn out. So in order to avoid that, what I am doing, I am just fixing the IC like this, so that this pin, the center pins, vertical section only connected, horizontal lines are not connected. So this pin and this pin will never contact with each other. So this is separate and this is separate, and all pins are looking fine. No short circuits will occur. This is the how we have to fix the IC. That's the first. Next, what I am going to do is I am going to take one power supply. You have to type power here. Power. Power means you will get this power supply button. So this power supply, how to connect? You have to, default value is 5 volts. So how to connect means this positive I have to take and connect to here. Automatically the wire will come. Okay, negative I have to take and I have to give. So you can change the colors of this also. If I click this means it is green color by default, but red color is for positive supply and black color is for negative supply. So once I fix this wire, what is the meaning? This entire thing are treated as negative terminal. These entire slots are treated as negative. You can ask plus minus is here, but no problem. This is just for hierarchy. If you want, you can replace. So as per norms, I need to connect means you replace this wire here and replace this wire back to the upper end. So that as per the hierarchy, topmost terminal, all terminals are now supplied with a negative component and all positive terminals are supplied with positive component. After doing this, what I have to do, I need to give inputs. For that, what I am doing, I am taking one switch. Switch is nothing but what? This is called as a dip switch. Dip switch means what? Here supply come means if I put switch on, this switch will, this supply will come out of this. That is which is on position and off position. Okay. Now what is the role of this? I have to connect supply to this by default. So what I have to do, I need to keep this switch like this. And what I have to do is from this positive terminal, I will take one wire and connect here. Similarly, take another wire and connect here. How many inputs AND gates is required? 2 inputs. One is A and another one is B, right? So what I am doing, I am changing this wire to A and this wire to, this is called as B. So both are red. So from top end, I will take one wire. Okay, listen here. This is important, and you have to give it to first pin of the IC here. This vertical component are connected, so I can give it at any slot. While this is nothing but input A, input 1A. That means A first in the truth table we give it as A and B now. So this is the first input. As per the logic, you are giving input A. Input B is nothing but my second pin that we will see here. So I will take another wire and give it to the second pin. And I am giving it to the second pin. Okay, now input A and input B is over. After that, what I am going to do is, this is very, very important. Here, if you touch means it is calling power button. This is 7th, this is a 14 pin IC. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14th pin is nothing but my power button. So what I am going, I am taking one wire and giving it to power button, and this is ground button. So what I have to do, I need to take one wire and give it to the negative end, giving it to the negative end, negative, right? Negative means you can see here, this pins, this negative wire is in touch with that wire, you can see, right? So after doing this, I need to do the realization. So take one resistor, okay, and turn that either horizontal or in that position. So you are not seeing that. So Okay, now you are seeing now. So what if you click that means it will show the value. So perfectly turn this. Okay, and then click here. So you can now take this and keep perfectly to anywhere like this. So how this connection should be made is one resistance. Why we are keeping this resistance means to protect the LED. LED is be the indicator. If 1 means it will glow, if 0 means it will remain in the off condition. So this one terminal should be connected to the output, and this free end should be connected to the LED. How to connect this I will now check you. So here for the LED we are having two inputs. One is called as anode and another one is called as cathode. Anode is a positive terminal and cathode is a negative terminal. Anode should be connected to third pin and cathode should be connected to the negative. So, but without directly connecting to the third pin, we are using one resistor in order to protect this device if any short circuits are happening or any additional source of currents are available. So from the third pin, I am taking one wire and I am giving to the resistor, and this resistance pin is directly connected to ground. You can see here, this pin I am taking here and connecting it to ground. Right, your connection is now over. Now what I have to do, I need to check with the truth table. So you have to start the simulation. If I start the simulation means initially what happened, 0 0, both switches are in off condition. That means what will be your output, 0 0 1. I am going to change this. You can see here, this is 0 1, no change, and then 1 0. This is 1. If you switch means this become 1, high and low. 1 0. If I give 1 1 means it is not blowing. Actually it has to blow. That is the thing. So why it is not blowing, we need to check. But this is the connection, how to realize the circuit. So 7408, why it is not blowing, we need to consider. So sometimes resistance, 1 kilo ohm resistance is used, no problem. So this is A pin and this is B pin, and this is my output. I am giving here. This is cathode and this is anode. So the LED is in the reversed form. So I am stopping the simulation and I am reversing this. So now you can see here, this become anode and this become cathode. Even small mistake also, now you can see here the LED is glowing. So if I switch this means you don't get 0 0 0 1 1 0. Now this is 0 1 and this is 1 0 and this is 1 1. So what you are getting? You are getting one light glow. So this is the operation what I am showing here. And gate 1 1, output remains what? Fine. Similarly, you can realize all these gates by yourself by using different ICs. So I am stopping the circuit, stopping simulation. Just I am replacing the IC with 7432. That means what gate? OR gate. OR gate you can take and perfectly fit here. Okay. So if I fit here means what happened? Nothing. That's all. Your gate will realize. You can see here 0 1 1. So 0 1. 0 0 only off, remaining on all condition it will remain in the on position. You can see here OR gate 0 0 0 1 1 0 1 1, everything is like that. You can very simply realize the operation by using your laptop. So once you realize this means these concepts will never get forgotten. Here you know how to write the program for this. Through program also you are verifying the output. Real-time implementation also you are verifying the output. Okay, so I think this is clear for you. One more thing I am going to show it to you, that is nothing but quite a little bit magic. What is that? Let us think. I am going to take one circuit. This new, right? This is called totally different. This is called micro blaze. Microblaze is nothing but a embedded processor. You no need to do any wiring. Last time we do some wiring, correct? Addition of power supplies, everything we are doing now. Here we are going to do coding. This coding, this is Python code. Same coding you are going to do here also, but in the form of func-based method. How to do that? Let us see. So here you take means you can see something is there already. Okay. So for example, I will discard this first and keep down for my, and after that we will see one by one. So first you have to take forever. Forever means what? Here there are so many boxes available. This is called block-based program. Basic, output, input, math, variable, control, everything is available. So one by one we will realize. So basic, you can see here, this LED will be available here, LEDs. And the output will be in the form of clear screen, plot, everything is available. Some random of functions are available. This input is nothing but these things, button A pressed, like that. So control is nothing but if statement, while statement, all these things are available. And mathematical control is AND gate, OR gate, all logics are available. One by one I will tell you how to do this program, same AND gate program. So first you have to pick this forever and you have to place it. Okay, this forever. And then you have to select the if statement. If true is there now, so you have to select the if statement and you have to place it. Fine. Then you can see here some button I need. So if button A is pressed, button B is pressed, how to do that? That is the thing you are asking, right? So what I am doing is I am going to take this math and here you will have if true A and B, that you have to select. So what I am doing is I am taking this box out and I am fixing this here if true. If button A is pressed, then what happens? So where you have see that button A is pressed, button A like that, if you see anywhere means you can check that, but button A is there or available or not, you need to first check out. So where it is available, that is the main thing what you have to do. So here, if I click here means you will get true, false, and or condition like that. So here I am going to just verify where it is available. So here you can see in the input button A pressed. Okay, so I am taking that box and I am fixing it. Fine. Slowly I am building. Once again button A is pressed, you take and fix here. That is button B is pressed. It is button B is pressed. So for operation, you can select either and or. Only two operations they have given. This is limited source only. So you have to give this. So output means this LED I have to take and I have to fix it. So this is if else. Only I have taken if. So if you want, you have to take if else condition. So I don't need to waste the time. Just I have fixed all these things. And if I want to discard this means, then what I have to do, slowly I can discard this. How means I can take and throw it in the dustbin. Okay. Here I will take this and I will throw it in the dustbin. Everything will be okay. So here you can take this shell called if else shell and you can follow all the logic. So first you have to take what are all the conditions I have taken. True and true. You have to take this condition only. I will once again, I will explain this. Then it will be understood. So everything I am releasing. Okay. Now if condition I have taken, control now. If condition I have taken. So this is default blocks. if condition I have taken. So I am removing slowly everything. Okay, for then you can understand easily. So also I am going and sorry, this also I can drop, but 1 minute. I will try to. Okay, this is drawing. This is also, yeah, this is online method. So now I think it is understandable. Forever, if true, then else this thing. So after that, I have to go to input and you have to select this box called A pressed. And before that, one more thing I need to take, math button, true and true, right? True and true. And after that, what I have to do, I have to go to input and you have to select button A pressed. And then you have to take button A, sorry, here it is come, 1 minute. So coding, so I think some mess up has happened, 1 minute. Yes. So, but first I need to fix this condition. So I am removing this and first I am fixing A true and true. And then I am fixing button A pressed, but it is not accepting. You can see here button A pressed is not accepting since you have to fix it very carefully. So here button A pressed, that you have to fix it exactly here. Okay, otherwise it will not fix. Then button A press, one more thing, when it is showing highlighted, then you have to keep and release this. That's all. Your work is over. Now you have to change this button A to button B. Button B. And for output, I have to take this LEDs. So here I have to take this LED, and here I need to show else condition. Another. If A and B, that means what it is showing, if both and condition, if A is pressed and B is pressed, what happened? This light should glow. So I need to, how it should go, your wish, that is, I can program. So what it will show is, 1 minute. So here, right. Now, if A, else it is should be in off condition. What I am telling, if A pressed and B is pressed, both are pressed means it should be on, otherwise it should be off. So if I run this simulation button, if I press simulation means what happened, you can check here. So if I am pressing A, you have to click the mouse here. Placed on this button and click the mouse, not flowing. Press B, not flowing. If I press A and B, you can see output is coming. You can see here now this output is coming. If I enable this also, then if I start the simulation, what happened? If I press both buttons, you can see whatever I am telling it will do. That means A and B, this is the thing. So if I want to do OR condition, then what if any one button is pressed also, this LEDs will glow. Let us check that. Both are not pressed. I am just pressing B button. See here, glowing. A button, glowing. Both buttons, glowing. No button is pressed. So this is called as micro blaze. Nothing, no connections, nothing. Only a fun-based program. Okay, only a fun-based zigzag arrangements of blocks. You can able to realize whether my circuit is working or not. So in many ways you can realize this digital logic circuit. But primary thing is, if you write coding, then this coding will support wherever you want. Since everywhere in this world, you need to embed coding into a particular processor so that it will work. So here also I am doing coding only. So main thing is you need to know how to code a processor. That is the very important. Designing part is separate, but coding level is now designing. That is you are developing one code means that code will help you to do some complex designs, and you can realize any complex circuit in your own fashion, or you can develop your own project and you can test it by means of Python tool whether the output is coming or not, and then you can implement that circuit. Means that realization is totally somewhat different. So anything is possible. So in this class we have completed how to realize this logic gates by using Python tool, as well as you know how to realize it in the simulation based also. Earlier we show IC based, now we are showing one embedded processor. This is called micro Blaze processor. In the internet also you can type what is mean by micro Blaze. If I type micro Blaze means a processor will come to your window. Micro Blaze Xilinx. This is the advanced FPGA processor. So if you click means soft microprocessor core. These are used for embedded programming. So it beneficial for various application across industrial, medical, automotive, and communication markets. So the main task is you need to know how to program this processors. So for that we are using Python codings. From this Python coding, you can convert that into equivalent code. That is different platform. But here we are realizing the circuit without doing any wire connection. Just by writing the logic, you can verify whether the outputs we are just studying is correct or not. We are just realizing. That is the essence of this module. So I think it is better understandable to you. So some assignments I have given in this course module. So better you can do that assignment and realize all the gates whatever I have mentioned, and verify all the truth tables with the help of Python as well as Tinkercad, so that you can able to realize how logic gates are really working. In the upcoming videos we will see how different logic circuits can be realized by using some different protocols. Next video we are going to see about universal gates. That is, two gates are going to act as a universal gates that are going to use to realize any circuits. How we are going to realize that circuit, how it can be realized by Python, and how it can be realized by using Tinkercad, that we will learn in the upcoming modules. Hope this lecture is very beneficial to you. I think so. So please do the assignments, and if there is any questions or any thing means you can raise in the question forum, so that I can able to answer you in a better manner. With that things, I am just completing the course. In the next module, we are going to see what is mean by universal gate. Here itself that is available. You can see here. This is pre-introduction only. Just you check this. So I am taking this. Here you can see here NAND and NOR 7400 and 7402. These two are called as universal gates. Suppose AND gate, OR gate, NOT gate, these gates are not available also. You can convert, you can realize all these gates with this help of NAND and NOR only. So NAND and NOR itself will act as a perfect replacement for all gates. Suppose you are going for a medical shop, you are asking for one tablet. That tablet is not available means what the medical practitioner will do, he will give you a equivalent tablet. That is more or less, that is not same, but it is equivalent effect. That like that, AND gate is not available means you can make NAND gate to work as that of AND gate. That conversions how we are going to do, what are the steps need to convert one IC from one mode to another mode, and how to realize that using the Python tool, that we are going to see in the upcoming session. So this main theme is to realize how we are going to experience the digital electronic circuit by using different tools. We are having Python tool, we are having Tinkercad, everything. But what is the use of these two tools? One is used to increase your programming concept. You can able to program and you can know what is the logic behind, what logic the AND gate is working. For example, here you can understand what is the AND logic. AND logic means A and B. Now we just extended the program for NOR gate, that is not of A or B. If you write this coding means what automatically come to your mind, A or B opposite, that is NOT gate plus OR gate is nothing but NOR gate. NOT gate plus AND gate is nothing but NAND gate. XOR gate is there, OR gate is there, AND gate is there. While you do this type of programming means automatically your mind will fix what is meant by AND gate, what are its output. If you have doubt also, what you can do, you can take your notebook anytime, you can run and you can verify. Instead of seeing and reading the books, you can read 00 means what it is doing. So AND means what? A and B both should be 1. You can directly realize that A and B both are 1. So answer is 1. So one more thing is here also one more gate is there. Like this also you can do in the form of widgets also. That widgets I will teach you in a upcoming. Since first itself I will go very vast means it will make you very feel you very bore as well as very vague. But what is the real thing I will tell. So these are called as interactive widgets. Just I will explain you what is this and I will wind up this module. So if I run this means what happened, same thing you will get, but here from base is 10, to base is 2, and the number I am giving is 10. So what answer you are getting? Number 10 from base is 10, to base is 2. That is what you understand. This is decimal to binary. The given number is 10. So it is equal, and what is the equivalent base? 10 is nothing but what? 1010. 8421 coding you can realize 8421. Okay, 8 plus 2 is 10. If I give number means it is giving the answer in base 2. Suppose from base is I am selecting 2 and 2 be binary to decimal. Okay, so decimal is 10. I am giving 1010 and then I am running this code. If I run this code means what you will get? Base answer is 10. Similarly, if I want to get, if I want to change this as 11, 1100, you can see here, whatever I am typing here, it is replaced here. This is called interactive widget. This is called as interactive widget. Here, if I change any numbers, 8 means it will change here. It will, if I change any 2 here means whatever I am changing here, that will be reflected here. That is called as interactive widget. Special option available in Google Colab to interact with the existing snippet. That is @parameter, hash @parameter. Usually hash is used for commenting, but here hash and means you can able to type anything that will be reflected here. So this is 10 from base to 16 hexadecimal. Number I am giving is 10. So what answer you will get? A. So if I run means you will get the answer as A in base 16. So this is another form of coding. This I will explain you in a separate session whenever interaction is required. This level of program is sufficient for this course. This type of realization is sufficient. But if you want some fun-based learning means you can go ahead with this also. So all these things are shared already in the notebook. You can go ahead and practice as much. Okay, thank you all, and we will see in the next upcoming session realization of logic gates using universal gates. Okay, thank you very much, and we will see in the next upcoming session.